Adam speaks truth 75% of the time. He draws a card at random from a pack of 52 well-shuffled cards. When asked if it was an ace of diamonds, his reply was yes. What is the probability that the card drawn was indeed an ace of diamonds? And this is a question that falls under the category of more difficult or harder probability questions. And this one in particular covers the topic of conditional probability, which, at least to me when I was back in my high school, was a little bit more difficult to grasp than regular probability concepts. So let me try to, through this problem, try to illustrate the concept of conditional probability, and hopefully it will be clear to the audience. So we start with representation of the event. So let's suppose that the event A represents the situation, the scenario when the card drawn is indeed an ace of diamonds. And the probability of that, so there are 52 cards in a pack, and the ace of diamonds is one of those cards. So the probability of that event happening is 1 by 52. And the probability of complement of A, which complement of A means not A, so that's 51 by 52. So it's simply 1 minus 1 by 52, which is 51 by 52. And just noting here that A complement represents the event that the card drawn is not an ace of diamonds. So let Y be the event that Adam says yes to whether the card was drawn. The card that was drawn was an ace of diamonds. So his reply was yes to the question if the card drawn was an ace of diamonds. So that's the event Y when he says yes. So what we are essentially asked to find out was, given the event Y, meaning that if Adam's reply was yes, what is the probability that the card drawn was an ace of diamonds? And in conditional probability, this is kind of the notation that we use. So P, A, then we use a bar, Y. So it means probability of the event A happening given that the event Y is true. So this is conditional probability, and usually there's a formula for evaluating conditional probability which goes like this. So conditional probability of an event A happening given an event Y is equal to the probability of simultaneous occurrence of both events A and Y divided by the probability of the event Y happening. And this may be a bit difficult to understand where this comes from. So it might be easier for us to explain if we use Venn diagrams. And Venn diagrams are often used in set theory problems, and I have used or explained the use of it in one of my previous videos. But usually we draw circles like this, and let one circle represent the event A, which in this case refers to the event that the card drawn is an ace of diamonds. And similarly, we have another circle, and that circle represents the event Y, which is the event that Adam says yes when he was asked the question if the card drawn was an ace of diamonds. And let's represent that circle by Y. So it represents the event Y. Now, note that the event A and event Y overlaps. So there is a common overlapping region, and in the notation of set theory, this is called A intersection Y. An intersection, like I said is represented in notation by an inverted U. And from the standpoint of probability, this will represent probability of simultaneous occurrence of both the events A and Y. So the way we read intersection, the best conjunction to put in instead of the intersection symbol is and, if that helps it make easier to understand. So A intersection Y means event A and event Y happening. Now, there is a part of the event Y that's definitely outside that zone of intersection, and that part is the event Y happening and event A not happening, because that part of the circle Y is not covered by any portion of the circle A. So it's outside the circle A, meaning the event A has not happened and the event Y is happening. So that's how we represent this part of the circle Y in terms of our set theory notation. So if I now get back to our problem and try to simplify in terms of this particular problem, what does A intersection Y mean? So it essentially means that the event A has happened, right? And Adam has said yes. So meaning that Adam has told the truth, that indeed, an S of diamonds was picked by him. So the event A happens, meaning that the card picked is an S of diamonds, and the event Y happening means that Adam has said yes, which means that if both the events occur simultaneously, then Adam speaks truth. So that's why this part may be represented simply as the event A happens and Adam speaks truth. Now, what about the part of the circle Y that's outside, that's represented as A complement intersection Y? So breaking it down in terms of the problem, so this part represents, so A complement is of course not A, so it means event A does not happen. But Adam still says yes, right? So he replies yes to the question whether the card drawn was an ace of diamonds. So this part of the circle represents the event A not happening and Adam speaking false, right? So these two are the representation in terms of the problem of how we describe those two parts of the event Y. So when we are asked to find the probability, conditional probability, what we are trying to ascertain is, given the event Y happening, what is the proportion of the event Y that includes the event A. So that's why we have the probability represented as P A intersection Y divided by PY. So now we have an understanding of what those different parts of the event Y mean, the one that overlaps with event A and the one that doesn't overlap with the event A. Let's try to evaluate those probabilities. So this part is simplest probably. So P A intersection Y means that probability that the card drawn is an S of diamond and Adam speaks the truth. So this would be simply 1 by 52. So that's the probability that the S of diamond is picked from the card of 52, from the pack of 52 cards. And we know that the probability of Adam speaking the truth is 3 by 4 because he speaks truth only 75% of the time, right? So that's 3 by 4. And if we multiply these two, we get this number 3 by 208, which represents the the PA intersection Y, the probability of the event A happening and Adam speaking the truth, meaning that Adam saying, yes, the card drawn was an ace of diamonds. Now, let's evaluate the other portion of the probability of the event Y, which is this A complement intersection Y. So the total probability of the event Y, so as it's clear from the Venn diagram, that should be the probability of A intersection Y and probability of A complement intersection Y. So that's the way we have broken up the circle Y, right? So when we find the probability, it's the sum of the probabilities of those two regions. And that's what I've written out in words. So PY, which is the probability of Adam saying yes, is equal to probability the card drawn is an ace of diamonds and Adam speaks the truth, which is essentially PA intersection Y from the previous step, right? Plus, now we go to the other region of the circle Y. The probability that the card drawn is not an ace of diamonds and Adam speaks false. And now if we evaluate this one, the first term is we have already evaluated in the previous step. And the second one, so the card drawn is not an ace of diamonds, meaning it's the A complement, like the probability of A complement. And that one we know it's 51 by 52 from the very first line we wrote down while solving the problem. Now, the probability that Adam speaks false, so that's also has to be considered. That has to be taken into account here. So it's the card drawn is not an S, so that probability is 51 by 52, and Adam speaking false. And we know that he speaks false 25% of the time, so that's why the probability is 1/4. So that's where we get 51 by 52 multiplied by 1/4. And then if you just do the math here, it comes to 54 by 208. So now if we apply the conditional probability formula, we know PA intersection Y, we know PY, right? And we just divide the two, and this is the answer we get, 1 by 18. So the probability of the card drawn being an ace of diamonds, given Adam said yes, is 1 by 18, which is actually greater than the probability of the event A happening by itself, which was, as we know, it's 1 by 52. So PA was 1 by 52, but now the probability of A happening given that event Y has occurred is 1 by 18, which is quite higher than the probability of the event A itself.